In this video, we're going to talk about inverses of permutations in S sub n, the symmetric group on n elements. So let's suppose that I have a sigma that belongs to S sub n. In fact, I'm going to start with an example just as a way of illustrating an important idea here. So let's say I have the following permutation in, let's say S sub 6. So I have the cycle 1, 3, 4, and then I have another cycle that goes 2, 3, 6, 5. You'll notice these cycles are not disjoint. I'm not trying to write this right now in disjoint cycle notation. I just have a product of two cycles here, a 3 cycle and a 4 cycle. And I ask, what is the inverse of this? Well, one thing that we can do is we can try first finding the inverse of each cycle. The inverse of one, 3, 4, for example. Well, I know that 1, 3, 4, that represents a function which sends 1 to 3, 3 to 4, and 4 back to 1. So the inverse of that should be a function which sends 4 back to 3, 3 back to 1, and then 1 back to 4. And that's exactly what this cycle will do. So the inverse of the cycle 1, 3, 4 is the cycle 4, 3, 1, and I might choose to write that in a little bit more conventional way. Conventional meaning I usually put the smallest number in the cycle first. So instead of saying 4 goes to 3, 3 goes to 1, 1 goes to 4, I say, well, 1, I start with 1, 1 goes to 4, 4 goes to 3, 3 goes to 1. So that cycle, or that notation expresses the same thing, just a little bit differently. And similarly, I could find that the inverse of 2, 3, 6, 5 is, well, I can just reverse that. I can say 5, 6, 3, 2. Which is the same as 2, 5, 6, 3. So just checking, the inverse will send 2 to 5, and the original cycle sent 5 to 2. So that makes sense. 5 goes to 6, up here 6 went to 5, and I can check what each of these elements does and see if it does the inverse of what happened here. Okay, so you might think, so I'm coming back here now, you might think the inverse of 1, 3, 4, 2, 3, 6, 5 would be this. It'd be, well, the inverse of the first cycle is 1, 4, 3, and the inverse of the second cycle is 2, 5, 6, 3. But I'm not sure, so I'm actually going to check this by writing down each of these permutations, both the original, which we'll call sigma, and this one, which I think might be sigma inverse, but I'm not sure. I'm going to write each of those using disjoint cycle notation and see if they still look like their inverses. So let's try sigma. I know that sigma is 1, 3, 4, 2, 3, 6, 5. I'm going to go ahead and write that as a product of disjoint cycles now. So I'm going to start with 1. I know that 1 goes to 3 over here. 1 doesn't do anything here, and then 1 goes to 3 here. So 1 goes to 3. Now for 3, I need to look at the right cycle first, because the right is the one that gets performed first. 3 goes to 6, and then 6 does nothing on the left. So 3 goes to 6. Okay, and then 6 goes to 5. 5 does nothing over here. So 6 goes to 5. And then 5 goes back to 2. 2 does nothing over here. So 5 goes to 2. And then what does 2 do? 2 goes to 3. And then 3 goes to 4. And then I think 4 goes back to 1. All right, so that's sigma. Now if I take this one that I'm calling sigma inverse, that's going to be 1, 4, 3, 2, 5, 6, 3. And what's that going to be in disjoint cycle notation? Well, it looks like 1 goes to 4. I'm going to compute a little bit faster this time. I think you've seen enough examples of how to take a product of cycles. So 1 goes to 4. 4 goes to 3. Now 3 goes to 2, and then 2 does nothing. So 3 goes to 2. And then 2 goes to 5, and then 5 goes to 6, and I think 6 goes to 3, which goes back to 1. All right, so these look like maybe they could be inverses of each other, but wait a minute. I think there may be a problem here. Because here I see 3 going to 6. 3 goes to 6 in sigma, so what should sigma inverse do? It should send 6 back to 3. It does not. It sends 6 to 1. So these are actually not inverses of each other at all. Too bad. Okay, so in other words, I know that this is actually not the case. It's not true that the inverse of that product of cycles is this other product of cycles. But then again, I think, well, how did I come up with that? I took two permutations, which I might call alpha and beta, and I said, well, alpha beta inverse is alpha inverse beta inverse. And we should know by now that that's actually not good group theory. It might work in an Algebra 1 course where everything's commutative, but in group theory, the inverse of alpha beta in general is not alpha inverse beta inverse, it is beta inverse alpha inverse. And that's because if I were to take this and multiply it by alpha beta on either side, I would get the identity. That's what it takes for everything to cancel out, is I need this to be adjoining to this if I multiply by this on the left, and if I multiply by this on the right, then I need beta inverse to be right next to beta. So if I think again about this sigma inverse, the inverse of 1, 3, 4, 2, 3, 6, 5. The inverse of that should be the inverse of the right-hand cycle, 2, 5, 6, 3, times the inverse of the left-hand cycle, 1, 4, 3. And just as a way of checking, let's write down the cycle notation for that. That's, let's see, 1 goes to 4, 4 goes to 3, which goes to 2, 2 goes to 5, 5 goes to 6, 6 goes to 3, and 3 goes back to 1. Now, if I look at that, let's pick a different color here. If I look at the original cycle, original permutation, and this new one, I think now we have a valid inverse, because here I have 1 going to 3, 6, 5, 2, 4, and then I'll look in reverse order here, 1, 3, 6, 5, 2, 4. So everything checks out. Hooray! So when I'm taking an inverse of a product of cycles, I need to make sure I'm mindful about the fact those cycles may not commute with each other in general, and therefore inverses need to take into account the order of the elements correctly. All right, one more thing. So what if I have a product of disjoint cycles? Because I've already demonstrated every permutation can be written in that way, as a product of disjoint cycles. So what about in general? With a product of disjoint cycles. So let's say I have a disjoint cycle notation. Let's say it's written as A11 through A1K1, A21 through A2K2, and so on. Remember, K1, K2, all those are the lengths of cycles. And then I almost used N here, but I don't think I want to use N. Let's use M instead. AM1 through AM K sub M. So M will be the total number of cycles, and then these things, K1, K2, Km, those are the cycle lengths. Well, what would be the inverse of all of that? What would be the inverse of the product of those cycles? Well, the inverse of this product, sigma, should be, and I'm going to remember, I want to start with the rightmost cycle first when writing down the cycle notation for the inverse. So it's this. And I'm just going to write down the cycles and say I'm inverting them first, and then I'll come back and actually do the inverting. And then the inverse of each of those cycles should be AM1, AMKM, on down to AM3, AM2. And the next one's going to be A21. And I'm taking care to write these so that the smallest element still goes first. And then this one over here is going to be A11 on down to A13, A12. Okay, and you can check that each of those cycles is inverted correctly, because here I have AM1 going to AM2, going to AM3, and here I have AM3 going to AM2, going back to AM1. So that really is the inverse, even though it looks very strange. But now, okay, so now I have a correct inverse written down. But remember, these cycles commute. These cycles commute because they're disjoint. So I actually can rewrite the inverse with the cycles in something resembling their original order, because all the cycles commute with one another because they have no elements in common. But it's only because of that that I can do this. It's not because this is in some way some general principle about inverses of products of cycles. In general, cycles should not be expected to commute. So I actually can do this as long as I have things in disjoint cycle notation. Okay, so just to give a brief example, if I have a disjoint cycle notation like sigma equals 1, 3, 7, 2, 5, 9, and then let's say I'm doing something in S sub 10 here, so let's say 4, 10, 8, 6. Okay, those are disjoint cycles, so I can say the inverse of sigma would just be 1, 7, 3, 2, 9, 5, and then 4, 6, 8, 10. That would be fine because the cycles I gave in sigma were disjoint and therefore commute with each other.